All right, hi class. So today we are going to begin topic 15 in our Envision textbook, which is all about geometry, which we've already done a little mini unit on it. So some of this will be a review, some of this will be new. The first couple lessons are things that we've already briefly touched on this year, so that's good. But before we got started with the actual Envision assignments, I did want to do one introductory video, which is just all about quadrilaterals. And I think that if you write this down with me on your own sheet of notebook paper, or I have plain white computer paper, it'll help you just like while you're working through your assignments to kind of keep your head straight. Okay, so up at the top, I'm gonna title this, My Quadrilateral, big word, Quadrilateral cheat sheet. Okay, so this is something that I would have maybe done like when we were in school and we were doing our actual learning in the classroom together, maybe in our math notebooks. And this is something that you just kind of keep with you as we work through everything. So the first thing that I want to talk about is two key vocabulary words. So the first one is a vertex. Okay, so a vertex of a shape, remember geometry is all about shapes. The vertex is the point where two sides meet. Okay, so that is the vertex. It's the little point where the two sides meet. And we'll draw a picture here in a moment. And then an angle is made in the space between where two sides meet. Okay, so the main difference between a vertex and an angle is a vertex is the point where the two sides meet, and the angle is the space where the two sides meet. I'm gonna draw a little picture to just kind of like show you, okay? So I'm gonna draw a rectangle. And first, let's look at the vertex, which when there's more than one vertex, it's called vertices. It's one of those irregular plural nouns, okay? So the vertices, which is more than one vertex, are all the points where the two sides meet. So here's one side, here's another side. The point where they meet is here. So that is a vertex. I'll put a V for vertex. This side and this side meet right here. So this is like that point. I'm just kind of like bolding them. Like if I was going to take like the bold feature, I would just kind of like make it a little bit darker. Here's a vertex right here. It's like the corners, like the very, 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 very tip point of a corner. Okay. These are all vertices. Okay. Now the angle is the space created in between, which is usually like on the inside of a shape. So inside here, like this space right here is the angle. So that's all of these inside. And sometimes you often see them either rounded like that, or sometimes there's like little squares in them, but that's like the inside corner of a shape. So those are angles, the space in between, and then the vertices is the little point right on the very, very tip of them. Okay, and that's going to be something that you really need to remember for 4th grade as well. So keep that in the back of your brain. Okay, so that is that. So I'm just going to try to like draw that. So keep in mind the difference between vertices and angles. So now we're going to kind of get into the different names of these different shapes. Okay, and all of the shapes that we're going to be talking about in this unit in 3rd grade is polygons. So I'm going to define what a polygon is real quick. And we've already talked about this together. But a polygon is a flat shape. So no 3D shapes, they all have to be flat. And it has straight sides. So flat shape with straight sides. Okay, so we're not going to be talking about any circles. all flat shapes with straight sides, no cubes, no prisms, nothing like that. Flat shapes, straight sides, and they all have to be closed. There's no like open shapes, which means that all of the corners connect together, okay? So now that we know that we're gonna be talking about polygons, more specifically, we're gonna be talking about quadrilateral polygons, okay? So first let's do some examples of polygons. So if it's a flat shape with straight sides, that means it could be like a triangle, right? It's flat, they're all straight. Could be like a square, could be a rectangle, could be like kind of like a strange shape, like maybe like a star. I don't know how good I can do at drawing a 3D star. It's the best that we're gonna get. These are all polygons, okay? A quadrilateral is what we're really focusing on at first, okay? Quadrilateral. So a quadrilateral is a type of polygon. A quadrilateral, if you look at this prefix right here, quad, which I'm gonna put like a little bit of a box around, quad, that means 4, okay? So a quadrilateral is a polygon with 4 sides and 4 angles, okay? So look at our polygon examples up here. There's 2 shapes out of the 4 that I drew that are quadrilaterals, and there are 2 shapes that are not quadrilaterals. Can you figure out which ones are not quadrilaterals? Remember, a quadrilateral has to be a polygon with 4 sides and 4 angles. So if you're thinking a triangle is not a quadrilateral, you're correct because it only has 3. If you're thinking that a star is not a quadrilateral, you're right because it has way more than 4 sides. So those are not going to work, okay? So some examples of quadrilaterals is going to be any flat shapes with straight sides that has 4 straight sides and 4 angles. So for example, we could have a square, we could have a rectangle, and it doesn't have to be exactly like this. It could be some of these like kind of like squished ones. Like it's okay because there's still 4 sides and there's still 4 angles to them. It could be like a diamond. That's a quadrilateral because it has 4 sides, 1, 2, 3, 4. They're all flat, they're all straight, they have 4 angles. So these are all examples of polygons. Now or quadrilaterals. So now when we're looking at quadrilaterals, there's even more special names for them, okay? And they're kind of grouped into like 2 categories, okay? So the first one, it's kind of like, separate this here, okay? So the first kind, I'm gonna scoot this up a little bit so I've got some more room, is that we could have trapezoids. Okay, so trapezoids are a type of quadrilateral. So trapezoids also have 4 sides and 4 angles. But now once we get into classifying these quadrilaterals, they have more special rules. And sometimes I like to think of it as like you have to have these special attributes. You have to follow these rules to be able to be called this shape or be able to go to like that club, okay? So like if I was thinking in my brain, well, what does a quadrilateral have to look like in order to go to the trapezoid club? So if a quadrilateral wants to go to a trapezoid club, it needs to meet all of these requirements. It needs to be a flat shape with straight sides to be a polygon. It needs to have 4 sides and 4 angles, and it also has one more extra rule. A shape that wants to go to the trapezoid club also has to have exactly 1, and I put that like in all capital letters because it's so important, exactly 1 pair of parallel sides. And we have already talked about what parallel and perpendicular mean, okay? So remember, class, think back to a couple of months ago when we first did our mini geometry unit. And we talked about how parallel lines are lines that never ever cross. So I'm gonna put, so parallel lines never cross. And remember, that doesn't mean they have to never cross like just in this shape. It means that they never ever ever will. If I were to draw that line forever and ever and ever, it will not cross. If that rule is true, then those lines are parallel. If they will eventually intersect, then they are not parallel. So a trapezoid has to have only one pair of parallel sides. So I'm going to show you an example, okay? So a shape that kind of looks like this is a trapezoid. This is the parallel lines right here, the top and the bottom, because even if I draw them out forever and ever and ever, they'll never cross. But these sides are not parallel. Do you see where they would eventually cross if I drew them out forever? They would cross eventually up at the top, right? Maybe out here, if I kept going, they would cross. So this is an example of a quadrilateral that has only one pair of parallel sides, okay? So the top and the bottom, those sides are parallel, the sides are not parallel. Here's another example of how it could look like. And they could have even like more examples than this, okay? So like for these ones, again, the top and the bottom of this shape will never ever cross, but the sides would cross because this one is slanted going this way. It would eventually cross like maybe like up here or something, okay? So this is another example of a trapezoid. I'm gonna draw kind of like a little cloud around it. Okay, so the next types of quadrilaterals are another big umbrella, and these are called parallelogram. All of these are like tongue twisters, kind of. Okay, so within quadrilaterals, all quadrilaterals, because they all have four sides and four angles, they're either trapezoids in which they have only one pair of parallel lines, or they're a parallelogram, which means that they have two sets of parallel lines. Two pairs. Okay, so two pairs of parallel lines, which means that both of the opposite sides are parallel, okay? Now, parallelograms also have some other rules with them too, and that is that opposite sides are the same length, okay? So when we're talking about opposite sides, the sets of opposite sides, just like when we were looking at this shape over here, are top and bottom, they're opposite of each other, and then the sides that are left to right. So remember, we can kind of think of it as like they're neighbors across the street from them, okay? So their sides on the opposite side of the street from them have to be the same. The top and the bottom have to be the same length, and the side and side have to be the same length, the right and the left sides, okay? And then also opposite angles are the same size. You got white kind of small, okay? So with parallelograms, two pairs of parallel lines. So if I were to look at the top and the bottom, those will never, ever, ever cross. If I were to draw out the left and the right sides forever and ever and ever, those sides will never, ever cross. And then the opposite sides are the same length and opposite angles are the same size. So you don't want a really acute angle on one side and a big obtuse angle on the other side, okay? So now that we're looking at parallelograms, there's special kinds of parallelograms, okay? So there's trapezoids, there's only one kind of trapezoids really. They just look like this, okay? As long as a shape can have one pair of parallel sides and that never ever cross is a trapezoid, okay? So with parallelograms, there's so many different types of parallelograms that they also get their own special types, okay? And there are 3. So I'm gonna do like a 1, a 2, and a 3. I'm gonna kind of like divide it out so that I've got some good space, okay? So the 3 types of parallelograms, let me move it so that you can see. Okay, the first type is, it might be called a rectangle. Okay, and in order for a parallelogram to be called a rectangle, it has to meet all of these rules because it's still a parallelogram, but also it needs to have 4 right angles, which remember, those are those square corners, and 4 right angles or square corners, okay? So that's all it needs. So this is a special parallelogram. We can write that up here too. Special parallelogram. I picked a long word to kind of like squish in there. Okay, so a rectangle is all of these things, and also all of its angles are those square corners, which means it makes like an exactly perfect corner, which is 90 degrees, okay? So those are angles that look like this, okay? So they are exactly up and down. Those are right angles or square corners, 90 degrees, okay? So then we could also have a parallelogram that we could call a rhombus. And in order to be called a rhombus, a shape needs to have all of these things to be a parallelogram. And a rhombus also needs all sides the same length. Okay? So that means a rhombus so it needs to have 2 pairs of parallel lines, opposite sides are the same length, opposite angles are the same size, and all sides the same length. So it's kind of like this second rule for parallelograms, but even more. So a rhombus could look like this. I tried to make them the same size. Or like this, okay? And a rectangle also, all 4 right corners. A rectangle could look like this too because it has all 4 corners, okay? So like we're looking at a rhombus, in order to be a rhombus, it doesn't have an angle rule other than opposite angles have to be the same size. So as long as this one's the same size as this one and this one's the same size as this one, it's good. Same thing over here, okay? A rectangle has to have 4 right angles, and it doesn't have a rule about the side lengths, okay? So that's why I think this cheat sheet is gonna be good for us, so you can kind of like keep it in your brain, okay? So both of these shapes get to be a rhombus, all right? And then the last one, the square, is the hardest one to get into, okay? The square club. Okay, so in order for a shape to go to the square club, it has to have 4 right angles. So just like a rectangle, it has to have 4 square corners or 4 right angles, and all sides the same length, okay? So a square has both of these rules at one time. So it has to have 4 right angles and all sides have to be the exact same length, okay? So that means that it pretty much can only look like this. 4 right angles or square corners, all sides the same length. This shape that I put for a rhombus cannot go to the square club because it doesn't have 4 right angles. It has like squishy angles or acute angles, right? When they're less than 90 degrees. And it has 2 obtuse angles too. This shape right here in the rectangle can't go to the square club because all of the sides are not the same length. It's got 2 long sides and 2 shorter sides, so it doesn't get to go there. But this shape, a square that looks just like this, it can be called, if it's kind of rectangular, pretend it's perfect. There we go, X that out. So this shape can be called a rhombus because all of its sides are the same length. It can be called a rectangle because it has 4 square corners. It can be called a parallelogram because it fits into that. And it can be called a quadrilateral. So you just have to look at each shape individually and kind of look at all of the rules that it needs to be there to decide if it can go to that club. The only club that this one can't go to on this paper is the trapezoid club because it doesn't have exactly 1 pair of parallel lines. It has 2. Okay, so hopefully that helps make a little bit of sense. If you want to kind of write this down with me, I'll go ahead and I'll scan it up into Schoology too. So if you want to write it down yourself, you can, or if you just want to print off mine that I made in our video, that's fine too. Whatever works best for you. And I look forward to learning more about geometry with you guys. Bye.